Um, Video presentation, where we are dealing with exponential limit is at 2. So to start with, we would define exponential 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 function are the exponential function, or simply is the function defined by f of x is equal to b to the power x, where b must be greater than 0, and that b itself must not be equal to 1, right? And that x also is a real number. Okay? Now, what this means implies that b, what this implies that b is, whereas x is an exponent. The exponent is an index. Right? That's that. Okay? That is b, an exponential function. Then we look at another definition for natural exponential function. Okay. Now, for all real numbers, let's say function defined by f of x equal to e to the power x called a for the natural exponential function. So e to the power x is a natural exponential function. E to the power x is just say an exponential function. Now, note that e represents some number. Okay? The number that, okay, that e equals to 1 plus 1 over n power n, right? At this approaches, which is how that number approaches 1, as any increase without bound. What we are saying that E represents the number that it is approaches zero as n is increasing for this function or for this function, right? As 1 plus 1 over n to the power n is approaching zero as n is increasing without bound. Basically, we are saying e to the power x is our natural exponential function, right? Then we look at another definition of logarithmic. So the function defined by log b of x, where b is the base, or maybe we say is a, is a positive, a positive real number for b is not equal to is called a of limit. Okay. Now the notation, right? The notation of b of x is simply read as logarithm, logarithm of log base b of x. So you simply say log b of x, okay? Log b of x. That's how you read it. Now, there's need of some marks you need to note. Number one, that f of x is equal to log b of x is the inverse, is the inverse of the function g of x equal to b to the power x, right? These are just the inverse functions. So b to the power x is an inverse function of log b of x. Now, since these functions are inverses, right? And because inverses have a property that when you combine f g of x, when you get a composite function for this function, right? The answer will be x. All right? Then we have the following theorem. What's theorem? Which is composition of logarithmic and exponential functions. This is very important. Now, we say let g of x be equal to b to the power x and f of x be equal to log b x. Right? For x is greater than 0, b is greater than 0, and that b is not equal to 1. Then if we want to find f g of x, right? So simply means now let me start with the g f of x. G f of x, all right? This simply means that get f here and put it in g. This is the same as g f of x, all right? By composite function. And this implies that f of x equal to b log b of x, right? And that the answer says they are opposite, they are inverse functions. When you combine a function with its inverse, we'll always get the domain, we'll always get x, so get x. All right? And we get f of x. This simply means we have log b of g of x. It's the same as log b of, what is g of x? B to the power x. This was a u x. Therefore, we have that y is equal to log b of x and x is equal to b of y are just different ways. of expressing the same. All right, so that is the different ways of just expressing one problem. Okay. Now, why we have done this also is to look at how we can deal with exponential and logarithmic expressions. So, exponential, they are the bases logs. Logarithm. How do you change form? How do you change from log to exponential? Now, for any positive real numbers, be x, y, number one, exponential form of this log form, which is log p of x, equal to, deal with your base. Our base is b. Then okay, there is y here equal to y. Is, if you want to express it now in an exponential form, we pick our base, which is, then you raise it to the power y after the equal sign. All right? You raise it to the power y, and the answer is x. This is the exponential form. All right? That is our exponential form. This power, whatever is made on the right hand side or left hand side as the case may be, and you equate to this number here, right? Number two, the log form is form of log b of x equal to y is, start with your base, start with um, the log form of an exponential form. Log form of b the power y is equal to x. So for this one, you're going to say your base is, you're going to say log of your base. Then you equate it to the power, we'll say equal to y. Then we want to find the log b of x. That is how you do that. Okay, let's look at some examples. All right. Then I will say in each one, log form, logarithmic form. A, 3 to the power 2 is equal to 9. B, x to the power 3 is equal to 10. And C, 2 to the power negative 2 is equal to 1 over 4. 2, exponential form. A, 4 is equal to log 3 of x. B, x is equal to log 5 of 7. And C, 2 log 2 is equal to log x of 5. D, 2 log 10 x plus C, 5. Okay, let's look at the solutions. That will be the end of this presentation. So the first one is 3 to the power x is equal to 9. We convert it to log, right? So we'll start with A, the log of the base, log 3, okay, of 9. So we equate the power here, all right? Equate the power, which is 2, then find that. So it's log 3, 9, log base 3, short of 9 is equal to 2, right? Then we have got x to the power 3 is equal to 10. Again, you start with your power, the log, start with the base of x is equal to the equal sign, you put the power, then here put 10. All right, that's it. Then see what we have. 2 to the power negative 2 is equal to 1 over 4. So this will have log of our base 2, and that we equate this to negative 2, then we have 1 over 4. All right, that's it. Then number 2, from logarithm exponential. A, 4 is equal to log of base 3 here of x. So what are we saying? Always start with the base, which is 3. So this, which is on the left-hand side, is our power. Then we equate this to what? To x. All right? That's how it's done. Then b, x is equal to log 5, which is a base of 7. So we'll say, start with our base, 5, the power, the equal sign here, x, and the answer is what? 7. And C, 2 equal to log x 5. So our power is x. Our base is x. So we equate to whatever is on the left-hand side, 2, and this is 5. Then D, we have we have got D, 2 equal to log over base 10. Log base 10 of x plus 5. Our base is 10, and 10 will be raised to the power 2 equal to x plus 5. And that is your answer. So that is where we end for this presentation. We're looking at the definitions of exponential functions, natural exponential functions, and logarithmic functions, as well as how to change from log to exponential, from exponential to log. Till next time, please share and subscribe. Bye-bye.